All right, so let's look at your sample test, if you would please. All right, so when you are adding and subtracting matrices, what has to be true? What has to be true about your matrices to be able to add them or subtract them? They have to have the exact same dimensions, the same order. So it can be a 2 by 5 and a 2 by 5. It can be a 1 by 7 and a 1 by 7. It can be a 2 by 2 and a 2 by 2, but they have to be identical. All right, so if we look at number 1, we have a 2 by 2 and a 2 by 2. Are we going to be able to add that?
Yes.
Yes. All right, so if we have a 2 by 2 and a 2 by 2, we will be able to add those. So literally I'm going to take what's in the first row, first column, plus what's in the first row, first column, and put it in the first row, first column. All right, so then 3 plus 1 is going to give us 4, and then negative 1 plus 4 gives us 3, and then 0 plus 2 gives us 2. All right, then look at number 2. For number 2, I have a 2 by 2 and a 3 by 2. Can I subtract those? Can you add and subtract if they have different orders? No. So I can't subtract those because in order to add or subtract, your order has to be identical. So I would just say undefined when it can't be done. Okay? All right, how about number 3? Am I going to be able to subtract number 3? I have a 2 by 2 and a 2 by 2? Yes. All right. So I'm just going to go through and say 2 minus a negative 1. That'd be 2 plus 1 or 3. 3 minus 1 would be 2. Negative 1 minus 4 is negative 5. And 0 minus 2 is negative 2. All right, what has to be true in order for me to multiply matrices?
Numbers have to be the same.
The what?
The inside.
Yes, the inside numbers in your order have to be the same. So for number 4, we have a 2 by 2 and we have a 3 by 2. The inside numbers are not the same. So again, it can't be done. And when it can't be done, I just say undefined. All right. So then for number 5, I have a 2 by 3 and a 3 by 2. My inside numbers are the same. So I can multiply. What do the outside numbers in the order tell me?
Are you going to put the final answer?
Yes, how I'm going to write my final answer. So the outside numbers, 2 and 2, tell me my answer is going to be a 2 by 2. That's really important because I have to come over here and draw out my 2 by 2 so that I can, if I'm trying to figure out what goes in the first row, first column, I can multiply first row times first column. If I'm trying to figure out what goes in the first row, second column, I multiply first row times second column. So I got to know what I'm trying to find to know what I'm supposed to multiply. Okay? So again, for this guy right here, first row, first column, I'm going to take the first row times the first column. So I'm going to do 2 times negative 1, 3 times 4, and 1 times 0. So that's what you see right here. That's how we're getting that 10. All right. This number right here, this is coming from this spot right here. What do we call that spot? What row, what column? What row is it? Rows go across, columns go up and down. So what row is it? First row, yes? All right, what column? Second column. So I'm in the first row, second column. So that tells me I'm going to multiply first row times second column. All right, so first row times second column. So now I'm going to do 2 times 1, 3 times 2, and 1 times negative 2. And so we can see that here, and that's where we're getting that positive 6. All right. Then this is second row, first column. So I'm going to multiply second row times first column. So I'm going to do negative 1 times 1, 0 times 4, and 2 times 0. So that's what we've got right here. And that combines to be the positive 1. And then for the last one, second row, second column. So we're going to multiply the second row by the second column. So we're going to do -1 times 1, 0 times 2, and 2 times -2. So that's what you see right here. That's how we're getting that -5. Okay? So any questions about 1 through 5? Okay, now number 6 is the last thing that we have to be able to do by hand. It is finding the inverse of a 2 by 2, and we just learned that. On our very last day of class, we learned that. So it's still pretty fresh for us, okay? So let's go through that to make sure that we're good with that, all right? So for number 6, they give us this matrix, and they ask us to find the inverse. All right, so we have a formula for finding the inverse. It's 1 over the determinant, and the determinant is just A times D minus B times C. So basically it's the main diagonal minus the alternate diagonal. All right, so for ours, A times D would be -1 times +6, so that would be -6 minus 4 times -2, so -8. So that's where we're getting this denominator right here, -6 minus -8. So -6 minus a negative, that'd be -6 plus 8, so that denominator would be 2. My determinant would be 2. So the first thing that we do is 1 over the determinant. Then we multiply that by a shuffled matrix. And here's what they shuffle. They switch A and D. So you can see it's DA instead. So we're going to switch -1 and +6. So you can see down here that they're in the opposite order. Now it's +6, -1, right? We're going to leave the -2 and the +4 where they are, but we're going to change them to the opposite sign. So we change our B and C value to the opposite. So this was a -2, now it's a +2. This was a +4, now it's a -4. So if I take 1/2 times that matrix, 1/2 of 6 is 3, 1/2 of 2 is 1, 1/2 of -4 is -2, and 1/2 of -1 is -1/2. Okay? So again, it's 1 over D, where D is the determinant. It's just the main diagonal minus the alternate diagonal. So we had -6 minus a -4. Minus a -8. So -6 plus 8 gave us a +2 in our denominator. Then in the matrix, these two switch places. These two stay where they are, but their sign changes to the opposite. And then we just multiply the scalar quantity times that matrix. Okay? So any questions about the things that you have to be able to do by hand? Okay, so from this point forward, everything that we do, you can do on your graphing calculator. So go ahead and grab your graphing calculator, if you would, please, so that we can use it. All right, so for number 7, they ask us to solve the system by graphing, and it says you must show work to receive credit. So I have to see a graph on your piece of paper, but if you want to graph it on your calculator and then just copy that onto your piece of paper, that's perfectly fine. So you can choose whether you want to graph it by hand or if you want to graph it on your calculator and then just copy that over onto your test. Okay, so let's look at it both ways. So if I'm doing this by hand, then basically I want to graph a line however you like to do it. Maybe you want to use the x and the y intercept. Maybe you use the slope and the intercept. Maybe you make an xy chart, whatever you want to do. So I took this first equation and I solved it for y, because if I'm going to put it in my calculator in a second, I got to solve it for y anyway. So I went ahead and I subtracted the 3x from both sides, and then I divided both sides by 6. All right, so that's my first equation. So if I plug some points in there, like if I put in 0 for x, I get 0 for y. If I put in 2 for x, I get -1 for y. So I've got 0, 0, and I've got 2, -1. There's 2 points. I can graph my line. All right. Then for the second one, again, if I'm going to put it in my calculator, I got to solve it for y first. So I'm going to go ahead and I'm going to get y by itself. So to get y by itself, I'm just going to subtract the 4x to the other side and then divide both sides by the negative 2. All right. So I've got y is equal to 2x minus 5. So again, if you put 0 in for x, you get negative 5 for y. So that's going to be down here somewhere. So maybe I want to put something different in, something easier. Maybe like I put 2 in for x. If I put 2 in for x, 4 minus 5 is negative 1. So that would be the point 2, negative 1. If I put 4 in for x, I'll get 8 minus 5, which is 3. So I could come plot the point 4, 3. So however you like to graph lines, we've been graphing lines for a couple of years now. Your solution equals what? Intersection, yes. So that intersection right there is my answer. And that intersection is 2, negative 1. So what you're going to put on your paper is you're going to put the graph. And then right below it, there'll be a line for you to put your answer. Your answer, your solution is your intersection. So you're going to put the 2, negative 1 in the answer blank. Okay? Now, if you would rather do that on your calculator, that's perfectly fine. All you need to do is put the two equations in y equals and graph them. Okay, so I've got my two equations there. I put them in y equals. That's the graph I get. I can look at that and probably see my point of intersection. But if I just want to be sure, I can get my calculator to tell me that point. And remember, the way that we did that was we went to second trace. That's our calculate menu. So second trace. And then we went down to number 5, intersect. All right. So when you choose number 5, it's going to ask you, do you want me to use what's in y1 for the first curve? I just hit enter to say yes. Then it jumps down to the second line and says, do you want me to use what's in y2 for your second curve? And I just hit enter for yes. And then it wants a guess, so I just go close to where I think my solution is and hit enter. Okay. So I know we've done that a bunch, but I just want to remind you of how we did that. And so it will literally flat out tell you the point of intersection. Now, a lot of people finish this test quickly. So if you finish and you worked it out by hand, go back and check it on the calculator. If you did it on the calculator, go back and check it by hand. Like, you know, double check and just make sure you've got everything perfect. So questions about number 7. All right, for number 8, it says solve by elimination and you must show work to receive credit. So even though this is a system of equations and you might be able to solve it on your calculator somehow, you have to do it by elimination and you have to show the work that you did that. Okay, so you can check it on your calculator, but it says that you've got to show your work, then you've got to do that. Okay, so elimination, remember, we want to get our coefficients to be opposites of each other so that they'll cancel each other out. So if I multiply this top equation by 3, I'll get 6x. And if I multiply this bottom equation by 2, I'll get negative 6x. So the 6x and the negative 6x would cancel each other out. That's what I want to happen. The most common mistake I see here is you multiply this side by 3, but you forget to multiply this side by 3. So just be careful that what you do to one side, you do to the other side. Okay? All right, so now we can go through and combine those. So 6x and negative 6x would be 0x. So that eliminated. It dropped out like we wanted, right? And then positive 9 and negative 10 would be negative 1. So negative 1y. And then negative 24 and 28 gives us 4. So if negative y equals 4, then what do I need to do to get y?
Inverse.
Okay.
Reverse the sign.
Yeah, so divide by negative 1 or reverse the sign. So yeah, I'm going to have y equals negative 4. Once you know y, how do you find x?
Plug y in for any of the equations.
All right, so we're going to plug y back in to find x. And I've got 1, 2, 3, 4 equations to choose from. You can use any one of them. All right, pick the easiest one. So to me, this looked like the easiest one. So that's the one that I copied. And so I'm going to put negative 4 in for y, and I get x is equal to 2. So what do I write in my answer blank? When it says, what's the solution? What I write in the answer blank is the ordered pair 2, negative 4. Now, I also asked you, what type of lines are these? Remember that solution equals intersection. So if you get one solution, how many intersections do you have? One. So that would be intersecting lines, right? And then they also ask us what type of system, because we had consistent dependent, consistent independent, and inconsistent. All right? So if they have a solution, it's consistent. If there's only one solution, it's completely independent of everything else. So it's consistent, independent. Now, just in case your version of the test didn't give an answer like this, maybe you do elimination and you get this. What does that mean when you get 0 equals 0?
Infinite many.
Yes, that means that we have infinitely many solutions. When you get an identity, that means that there's not just one answer. There are infinitely many solutions. Y'all, you do not write 0 equals 0 in the answer blank. It said solve. This is your solution. What's in bold is what you write in the answer blank. Okay? So when it's intersecting, I'm just going to give the ordered pair for my solution. If it's infinitely many, don't say 0 equals 0. Say infinitely many solutions. All right? And then the type of lines, those are overlapping lines. And because we have a solution, it's consistent, but all of these depend on each other because they're all part of the same thing. And so it's consistent dependent. All right, so then last but not least, if you get 0 equals 4, what does that mean? Does 0 equal 4? No. So what does that mean? No solution. All right. So solution equals intersection. If there's no solution, that means your lines don't intersect. That's got to be parallel lines, right? And if it doesn't have a solution, then it's inconsistent. Okay? So whichever version of the test you happen to have, whichever one of those answers you might get, that way you would have all of them in addition to just the one that was on the notes. Okay? All right, so questions about number 8. All right, then number 9. For number 9, they ask us to solve the system by substitution. And again, it says that you have to show work. So you can check this on your calculator, but you have to solve it by this method and you have to show work. All right, so when we do substitution, we're going to choose one of the two equations and solve it for one of the unknowns. Okay, so here's my two equations. Which one of those looks easier to work with? X plus y equals 4, right? So yeah, that's definitely the one I want to solve. And I could either solve for x or y. It doesn't make any difference. If I solved for x, I'd have to come over here and square it. If I solved for y, all I'd have to do is distribute. So I chose y just because that looked like the easiest way to go. But you could choose either one and you'd still get the right answer. Okay, so I solved for y. And then substitution is I take whatever y equals, that 4 minus x, and I put it in the place of y in the other equation. All right, so now I've just got a simple equation that I can solve. So I'm going to distribute my -3. So -3 times 4 is -12, and -3 times -x is positive 3x. And then I could combine my -12 and my 8, right, to be -4. Now that's a quadratic. If it happens to factor easily, fabulous. If it doesn't factor easily, y'all, I'm on the part of my test with my calculator. Just run the quadratic program on your calculator, right? And it'll spit out the answers for you. Okay? So once I find x, what do I need to do?
Plug it back in.
Plug it back in to find y. All right? And again, I want to plug into the easiest equation I can. So when I go back and I've got this guy and I've got this guy, this is definitely easier. And I've even already solved it for y so that I could go back and say, okay, y equals 4 minus x. So if x is -4, put in -4 right there. That would be 4 minus -4. That'd be 8. So when x is -4, y is 8. All right, then let's try the other x value that we got. The other one we got was 1. So let's take 1 and plug it in. So again, y is 4 minus x, so that'd be 4 minus 1, or 3. So when x is equal to 1, y is equal to 3. Okay? So those would be my two solutions, -4, 8, and 1, 3. Now, I had to do that by hand. I didn't have a choice. It told me I had to show work. But if I have time, I might want to check it on my calculator just to make sure I got it right. So if I've gotten everything else done and I'm going back and checking, what I could do is put both of those equations in y equals, so of course I got to get y by itself on one side, right? So put both of those equations in y equals and graph it, and then we're going to do the exact same thing that we were doing just a minute ago, where I'm going to do second trace, which is calculate, and I'm going to choose intersect. And basically I hit enter 3 times. Like it says, do you want me to use this for the first curve? Enter for yes. Do you want me to use this for the second curve? Enter for yes. And then whichever point of intersection you want, you guess closer to that one. So if I guess closer to this one, it'll give me this point. If I guess closer to this one, it'll give me this point. So you can see it gives me those same 2 points of intersection that we just got. Okay? Questions. All right, look at number 10. All right, so for number 10, this is another one of those that you can graph it by hand, or you can graph it in your calculator and just copy the graph off of your calculator onto your test. Okay, so we're solving by graphing. You can do it either way. Now, we know how to graph y is greater than or equal to x squared. That's one of our toolkit functions. Y equals x squared is just the parabola. How do I know if I make it dotted or solid? How come one of these is solid and one of these is dotted?
If it's greater than or equal, or just greater?
Yeah, so if it has an equal to with it, it's solid. If it doesn't, it's dotted, okay? So like for our parabola, it had an equal to. So that's why when we graphed our parabola, it's a solid line. But when we did our line, it was just less than. It did not have an equal to with it. And so that's why our line was dotted. So we already talked about graphing the parabola. For your line, again, you can graph that any way you prefer to graph a line. We've already done that a couple of times today anyway. The thing that's different about this is that you have to shade. Now, some of you use different colors for this. Some of you like shaded one direction and then a different direction, whatever you need to do. But to figure out, let's start with the line right here. I want to figure out, if this is my line, I want to figure out, am I going to shade up here or am I going to shade down here? And the way that I do that is with a test point. Okay, so I'm going to use the point 0, 0. So if I plug in 0, 0, I get 0 plus 0 is less than 12. 0 is less than 12. That's a true statement. So that lets me know, hey, that's a solution. So every point on this side is going to be a solution. So you'll notice that I shaded on this side for my line. All right, now let's go check the parabola. So for the parabola, we've got y is greater than or equal to x squared. I can't use 0, 0 this time because that's a point on the parabola. So I'm just going to use 0, 1. Okay? So if I put 0 in for x and 1 in for y, I get 1 is greater than 0. That's true. So that lets me know I'm going to shade on the inside of my parabola. Now, I need you to show me some way that you know what your answer is. Yes?
How do you change the equal sign to greater than or less than?
We're going to do that in just a minute.
Okay.
All right, so I need you in some way to show me you know what the answer is. Solution equals intersection. So again, just this little piece right here is my solution. So you can use highlighter and highlight that part, or you can just like take the side of your pencil and shade in here to make it a little bit darker, just so that I can see you know what that answer is. Okay? Now, that is a lot of work. And this is one question that I think might be faster and easier to do on the calculator. So I want to remind you of how we do that. All right? So to begin with, we've got our equations. I'm going to jot them down because that's going to go away when I pull the calculator up. So we have y is less than 2 minus 2/3 x. And we have y is greater than equal to x squared. Okay? So grab your calculator if you would please. All right. When we did this before, we turned on the inequalities app. So if you have turned it back off, you'll need to turn it back on again. But otherwise, you can just leave it on. If you shut your calculator off, it stays on. Okay, so again, it's in apps, and you can see that highlighted in red there. It's in apps, and then I go down to inequalities. And so because mine's already running, it's asking me, do you want to quit or do you want to continue? Okay, so I'm going to tell it continue. If yours was not turned on, then you would need to do that. Okay, so here's how I can change my equal to, because you can see down here they're all equal to, right? So here's how I can change my equal to something different. And it depends on what kind of calculator you have. For the ones that are color that you plug into the wall, you're going to use your arrow key and come over to Y1. And when you do, that whole box highlights. And when you hit enter, then it gives you all kinds of different options. So right now, if I go left and right, I'll change the color. I'm going to come down here. So if I come down here, you can see if I go left or right, I'm changing it to whatever sign I want. Okay? So for us, it was y is greater than or equal to x squared. So I'm going to choose greater than equal to. And when I do that, my calculator automatically knows to do a solid line and to shade above. I don't have to tell it that. I don't have to use a test point. Now, if you don't have the color calculator, if you have the kind that you put the batteries in, it's going to look a little bit different. And let me see if I can switch mine over. Yes.
Mine doesn't do that. I'd like a 83 plus.
There we go.
It does that.
It does not have that app.
Yeah.
But here's what if you have the older calculator, when you go to y equals, if you sit on top of your equal sign, now I don't have the inequalities app on this one. It just, like you saw when I change over, it cleared my RAM. But if you sit on top of your equal sign, down here, you'll get little buttons where you have like greater than, less than, greater than equal to, less than equal to, equal to. All right. Right below those buttons are F1, F2, F3, F4, and F5. So if you just hit alpha and then whichever button you want, it will select that and put it there for you. Okay. So if you don't have the inequalities app, you can still do it that way. And then you can come over here and tell it if you want it to shade above or below. It doesn't do the dotted solid thing, but it will let you shade above or shade below. Okay? All right. So let me go back to the other one. So we've selected greater than equal to. And so we're going to come down here and choose OK. All right, and then I can come down and do the same thing with this one. So I'm going to hit enter, and it'll let me choose the less than. And notice that when it chooses less than, it knows that it's dotted and it knows to shade below. So I don't have to do the test point. I don't have to figure out whether it's dotted or solid. It'll do all that for me. Okay. So now when I graph, that's the exact same graph we got on our piece of paper. So you are welcome to graph it on the calculator instead and just copy it over onto your piece of paper. That's perfectly fine. And again, this is the part that you want to shade darker, right where they overlap. Okay. So questions about that one? All right, so again, I tried to put that on your note sheet for you, how we did it by hand and how we did it on the calculator. All right, number 11 is a system of 3 equations with 3 unknowns. We have learned about 4 different ways to solve this. You know, there's the whole combine equations 1 and 2 and combine equations 2 and 3 and get equations 4 and 5 and combine those and back substitute. You use half a sheet of paper, right? We learned a fast, easy way yesterday to solve a system. And that was to take the system and rewrite it as an augmented matrix. Remember, that's just where you pull the numbers out, right? Okay, so we can take the system that they give us, and we can pull out just the numbers. So when we pull those out, that creates our augmented matrix. Then we want to do reduced row echelon form on our calculator. All right. So let's go back and practice doing that as well. Okay. So the matrix that we want to put in is 1, 2, negative 3, negative 10, 2, negative 1, 4, 15, negative 3, 3, negative 2, negative 12. All right, so we're going to go to second, x to the negative 1. That's our matrix button right there, lit up in red. And I'm going to choose that first one right there. Just kidding. I'm going to go over to edit and then choose that first one right there. And I have a 3 by 4. So I'm going to tell it 3 by 4. And then I'm going to enter those values from our augmented matrix. All right, so go ahead and put those in if you have not already. All right, so once you get your matrix in, we put it in A. You could put yours anywhere, but we put ours in A. We're going to go second matrix. And remember that if you go over to math, and it's actually closer to the bottom, so it's easier to scroll up, I'm going to scroll up to reduced row echelon form. Okay, so again, I did second matrix. I went over to math. And I scrolled up to reduced row echelon form and hit enter. Okay, so I've got that on my screen. Now I have to tell it what to take reduced row echelon form of. I want it to do matrix A. So I'm just going to do, again, second matrix and choose that A right there. And that's how fast it solves my system. Now, what am I going to write on my paper for my answer?
What, X, Y, and Z?
Yes. I'm not going to write that matrix. That matrix is not my answer. The matrix just helped me find my answer. It's 1x plus no y plus no z is equal to 1. So it's x equals 1. No x, 1y plus no z equals negative 1. So y equals negative 1. No x, no y, 1z is equal to 3. So z is equal to 3. The easiest way to write that is just to write it as an ordered triple. So just to say, okay, x, y, z. So for our values, x was 1, y was negative 1, and z was 3. So that's how I would write my answer, just x, y, z. And so that's what you'll see here on your note sheet as well, is that we've just written it X, Y, Z. That's what you want to write in your answer blank. That's your solution. Okay. All right. Then for number 12, they ask us to give the order of the matrix. All right. So how many rows does it have? 2 rows go across, right? And then columns go up and down, so 3 columns. So its order would be a 2 by 3. All right. Then every entry has its own little subscript. So if they want me to find a sub 2, 3, that's in the second row, the third column. So second row, 1, 2, 3, third column is going to be that 2 right there. Okay. And again, these are just the reminder notes down here about how we did the reduced row echelon form. So questions on that one? All right. So let's look at these last ones. All right, so first off, for number 13, I have 2 matrices, and it's a 2 by 2 and a 2 by 2. So how do I know if I can multiply? The inside numbers have to be what? The same. So because my inside numbers are the same, then yes, I can multiply these. All right, now, y'all, you're on the calculator page. Like if you don't want to do matrix multiplication by hand, you don't have to. All you'd have to do is just enter the two matrices and tell your calculator to multiply them. All right? So 2 different ways that you could do that. You could go put the matrices in A and B. So just like we were editing a moment ago, you could go put one of them in A and one of them in B. And then you could tell your calculator, hey, take matrix A and multiply it times matrix B. So we did this in class yesterday with quite a few of these. Okay, so that would be one way I could do it. The other thing that you could do is if you like that dedicated matrix button, not all of you have this, but if you like that dedicated matrix button, remember that you can just come up here and tell it, hey, I want a 2 by 2. It puts a blank one on your main screen and you can put the numbers in there. And then once you get those numbers in, you could come over here and tell it to multiply that by and do the exact same thing again. Okay. So if I had my calculator as an option for doing the problem, yeah, I definitely for that one would. So I did work it out both ways though. I did work it out with the work it out by hand. And then I did show you that you get the same thing over here with the calculator. Okay, so either way you want to go. All right, 14 is finding the inverse of a 3 by 3. And the only way that we did that was with the calculator. All right, so to find the inverse of a 3 by 3 on your calculator, remember that this is, just kidding, this is your inverse button, that x to the negative 1. All right, so I'm going to go to matrix and I'm going to edit matrix A. And it is a 3 by 3. And I'm going to put in what we've got there. All right, so we've got 1, 2, 3, 0, 1, 4, 5, 6, 0. So when I go back to my main screen now, I can just say, okay, take matrix A and do the inverse. So again, that x to the negative 1, that's my inverse button. So again, we don't have any other way of doing that except for the calculator doing that inverse of a 3 by 3. All right, for number 15, I almost think this would be faster to do by hand than it would be to do in the calculator. So I worked it out by hand. I think by the time I would have typed this whole spiel into the calculator, I could have done it by hand a whole lot faster because it's just adding and subtracting, right? So to begin with, I have a scalar multiple of 3. So I'm going to take 3 times each of these values. All right, so 3 times 1 was 3. 3 times negative 3, negative 9, 3 times 6, 3 times 2. And then over here, I'm going to take 2 times each of these values. All right, so we took 2 times each of those values, and then we're just subtracting. So again, by the time I typed that whole thing into my calculator, I probably could have done it by hand a couple times. But if you have time, go back and check it by typing it into your calculator and making sure you get the same thing. Okay? All right. 16, on the other hand, I would definitely do on my calculator because for 16, I can either do all of this work down here or I can do this. I like that idea a little bit better, right? Like this is just a whole lot easier. Okay, so for number 16, we're solving a matrix equation. We said there would be 2 steps. Find the inverse of A and multiply it times B. So all I have to do is tell my calculator, this is matrix A, take matrix A and find the inverse of it, and then multiply that by B. So if you'd rather work it out by hand, here's that same thing we were doing with finding the inverse of a 2 by 2 on the first page. And then it's just normal matrix multiplication. So if you'd rather do it by hand, you absolutely can. But you can see this is going to be a whole lot faster and easier. All right. And then the last thing for number 17, we were just giving the augmented matrix. The main thing for number 17 is you need to rewrite that system first. Because if you'll notice on your sample test, it's 4x plus 2y. I got to fill in 0z. And then it's negative 3z plus x. I got to put that in order. I've got to put the x first and fill in the 0y, and then there's my negative 3z. And on the last one, it was y minus z equals 4, so I got to fill in the 0 for x, and then y minus z equals 4. So if I'll rewrite that system first, then all I have to do is just pull the numbers out for my augmented matrix. So just watch out for that. Okay, so any other questions about anything on your sample test? As always, if you know how to do the sample test, you're fine. There's nothing on the test that is not on the sample test. Okay?